This lesson is for Mrs. Cucci's College Now Contemporary Math class. We are on lesson 2.2, and we're going to be talking about subsets today. All right, so what is a subset? So a subset is a situation where all of the elements of one set are also elements of another set. Okay, so another way to say that is set A is a subset of set B. I need my pen. And we can express that as A is a subset of B. This is notation. You'll get used to this. Okay. If every element, all of them, every single one of them, in A is also in set B. Okay, so all of the objects or elements in set A have to be in set B in order for it to be a subset. Okay, so, and I don't know why, but I'm missing my little line here, so just jot that in. Okay, so we're using subset, and obviously this would be not a subset, right? So we're going to write these in each blank to figure out if it's a true statement. So here's set A, 1, 3, 5, and 7. That's set A. Set B is 1, 3, 4, 7, 9, and 11. Is A subset of B? Well, we have to check. Is every element A in B? So here's 1, here's 3. Uh-oh, 5's not in there. So set A has an element that's not in B, so that means it cannot be a subset. Pretty simple. Okay. So the next one, X such that X is a letter in the word proof, Y such that Y is a letter in the word roof. So is A subset of B? Okay, so we're looking to make sure that all of A is in B. Okay, so first letter, P has to be in B as well. So is it there? It's not. So again, not a set. Let's do another one. X such that X is a planet of Earth's solar system. And we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So if I have a planet in Earth's solar system, are they all a member of that group? Okay, so all of the planets in the solar system are listed here, so that is going to be a subset. Okay. All right, so let's talk about proper subsets next. A proper subset is a given set that are kind of equal. Okay. So every set has to be like a subset of itself. So we're going to see what that looks like. So how we write it out is we say that set A is a proper subset. So that's the vocab word, right? Set A is a proper subset of set B expressed, here's the notation, proper subset. If set A is a subset of set B and sets A and B are not, there's a key word, equal. Okay, so A cannot equal B. So it's a proper subset if A is a subset of B, but the sets are not exactly the same. Okay? Okay, so we're going to write our notation here. So using the symbols subset and proper subset, we're going to choose. So X such that X is a person and X lives in San Francisco. Okay. For set B, X such that X is a person and X lives in California. So does every single person who lives in San Francisco also live in California? So that's the question we have to ask ourselves, okay? Is it a subset or is it a proper subset? So I would say that every person who lives in San Francisco is also a person living in California, since San Francisco is in California. So we can say that this would be a proper subset, okay? Because yes, A is a subset of B, but A is not exactly the same as B. I'm not saying everybody lives in California and then everybody lives in California again. Okay, so that's what we call a proper subset. The next one, I've got set A is 2, 4, 6, 8. Set B is 2, 8, 4, 6. Is A a subset of B? Well, yeah, here's 2, here's 4, here's 6, here's 8. So it's a subset, but we have the same exact elements here. So that's going to be a proper subset. Okay, so that's how you tell the difference with those. All right, so let's talk about the set of a subset. So we're going to let A be the empty set, and we're going to let B be the set 1, 2, 3, 4, 5. Is A a subset of B? Is A a subset of B? All right, so A can't be a subset of B. If there's at least one element in set A that's not in set B, then it doesn't work for us, okay? This doesn't contain any elements, so there's no subset to be found. So an equivalent of that would be this, okay? So we're going to say A is not a subset of B. The empty set can't be a subset of anything. Okay? So for any set B, the empty set is an element of B. For any set B other than the empty set, it's a proper subset of B. So don't worry too much about that. Okay? I'm sorry, I said that backwards. The empty set is a subset of every set. So I'll say that again. The empty set is a subset of every set. All right, number of subsets. Okay, so the number of subsets of a set with n elements is 2 to the n. So it's a little formula you have to have, okay? So to figure out the number of subsets in a set, you use 2 to the n being the number of elements within. The number of proper subsets of a set is going to be 2 to the n minus 1. All right, so let's see how we can find those. I'm going to find the number of subsets and the number of proper subsets for each. So I've got A, B, C, D, E. This is a set, right? I have 1, 2, 3, 4, 5. So the number of elements that I have is 5. So to determine the number of subsets, I'm going to be doing 2 to the 5th. Pop that right on my calculator, I get 32. The number of proper subsets is 2 to the 5th minus 1, which is going to be 31. The next one is x such that x is a natural number, so we know 1 through, right? You're counting numbers. And 9 is less than or equal to x, and x is less than or equal to 15. So it's all of the values from 9 to 15. So we have to know how many that is. We can count them out. 9, 10, 11, 12, 13, 14, 15. There's 7. So again, just use your formula. 2 to the 7th. You can put that right in your calculator. 128, and 2 to the 7th minus 1 is 127. Okay, guys, that's it for this lesson. So you're going to do 2.2 practice document next, and I will see you tomorrow.